day, viewers. My name is Audrey Polton. Welcome to Lesson 3 for Grade 9 Physical Science. Today we will learn about pressure. Let's have a look at the lesson objectives. By the end of today's lesson, you should be able to explain the relationship of pressure between force and the area the force acts on. Use the formula of pressure to do simple calculations. Now that you have seen the lesson objectives, we can start with the lesson. The force that is exerted on a unit area of a surface is called pressure. The SI unit of pressure is Newton per square meter or Pascal. 1 Pascal is defined as the pressure exerted on a surface area of 1 square meters by a force of 1 Newton. That is, 1 Pascal is equal to 1 Newton per square meters. The formula for calculating pressure is equal to force divided by area. Or in symbol form, it is P is equal to F divided by A. A quick way of remembering how to calculate one of either pressure, force or area using the other two is to use the triangles on the screen. The horizontal line means divide and the times symbol means multiply. We then cover up the one we want to find, represented by a red circle, and substitute values into the formula for the two remaining quantities in the triangle. Let's do an example. A force of 150 Newton is being applied over an area measuring 0.50 square meters. Calculate the pressure on the object. We're looking for pressure, so constructing the triangle and covering up the P, we must divide the force by the area. So P is equal to F divided by A, which gives us 150 Newton divided by 0.50 square meters, and that is equal to 300 Pascal. We'll do now example 2. A woman is applying 300 Newton per square meter of pressure onto a door with her hand. Her hand has an area of 0.02 square meters. Work out the force being applied. We're looking for force. So constructing the triangle and covering up the F, we must multiply the pressure by the area. So F is equal to P multiplied by A. And that is equal to 300 times 0.02, which is equal to 6 Newton. Example number 3. A pressure of 150 Newton square meter is experienced when a force of 2000 Newton is applied. Calculate the area over which the force is applied to obtain the pressure stated. We're looking for area, so constructing the triangle and covering up the A, we must divide the force by the pressure. So A is equal to F divided by P, and that is equal to 2000 Newton divided by 150 Newton square meters, and that is equal to 13.3 square meters. Let's now discuss why the spoor of a springbok is usually deeper in the sand than that of a heavy animal such as an elephant. From the formula for calculating pressure, we can see that pressure depends on the force as well as the area. Pressure is directly proportional to the force, meaning if the force is increased at a certain rate, the pressure will also increase. Pressure is also inversely proportional to the area, meaning the smaller area will cause more pressure. The springbok's foot has a smaller surface area. Thus, it exerts more pressure on the sand, making deeper spoor compared to animals with foot of large surface areas like elephants. We have come to the end of the lesson. Let's have a look at the lesson summary. The force that is exerted on a unit area of a surface is called pressure. 1 Pascal is equal to 1 Newton square meters. The formula for calculating pressure is equal to force divided by area, or in symbol form is P is equal to F divided by A. A quick way of remembering how to calculate one of either pressure, force or area using the other two is to use the triangles on the screen. The horizontal line means divide and the times symbol means multiply. We then cover up the one we want to find, represented by a red circle, and substitute values into the formula for the two remaining quantities in the triangle. A springbok makes deeper spoor than an elephant because a springbok has a foot of smaller surface area. Pressure is indirectly proportional to the area. That's why the pressure of the springbok spoor is larger than the elephant spoor. Pressure is directly proportional to the force. And this is the end of our lesson. Goodbye, until next time.